All right, so today we're learning about graphing linear equations. I know I've got this when I can identify linear equations and graph an equation by finding and plotting ordered pairs. So the key vocabulary is a linear equation in two variables and standard form. So a linear equation in two variables is an equation that can be written in the form ax plus by equals c, where a, b, and c are real numbers, and a and b are not both zero. The graph of a linear equation in two variables is a straight line. The form ax plus by equals c is called standard form. Now I do have to say, in standard form, a has to be positive, and there are no fractions or decimals. That's very, very important. So in standard form, A has to be positive. B and C can be negative, that's fine, but A has to be positive. And I kind of remind everybody, because you want an A plus. Okay, so A has to be positive and there can be no fractions or decimals. A linear equation will not have the following. Any variables with an exponent other than 1, so you can't have like x squared. Any variables in the denominator. Now, any variables in the numerator is fine, but you can't have any in the denominator, okay? Any variables in a radical. You can't have any variables being multiplied together or any more than two different variables. So you can't have x plus y plus z. All right, so determine whether each equation is linear equation in two variables, then explain why or why not. So you don't have to, if it is, you don't have to say why, but if it's not, you do have to say why not. So is A. Yes. Basically you say, okay, does it have any of those things that I said it couldn't have? And then that's why. So B, you would say no, because it has an exponent. C, yes. D, no, because two variables are being multiplied. E, yes, that's fine. F, no, because there's a variable in the denominator. Okay. So now this is one for you to do. So determine whether each equation is a linear equation in two variables, then explain why or why not. So pause it and try. Okay, so A and B are linear equations. C is not because there is a variable and a radical. All right, so we are going to graph the linear equation. All right, so how we're going to graph in this section, there's lots of ways to graph. In this section, we're just going to be plugging in numbers for x and finding out what y would be, okay? So all we're going to do is I'm going to plug in a -3 in for this x. So if I did that, I would get 2 times -3 minus y equals -4. So that would give me -6 minus y equals -4. I would add 6 to both sides, and I would get -y equals 2. So y equals -2. Okay, then if I plugged in a 0, I'll do that one down here. 2 times 0 minus y equals -4. That would just give me -y equals -4. I would divide by 1, and I would get y equals 4. Then if I plug in a 1, 2 times 1 minus y equals -4. 2 minus y equals -4. Subtract 2 from both sides, and now we get -y equals -6. So y equals 6. Now what you're going to do is you're going to plot all of these points, okay? So we're going to go -3, -2, 0, 4, and 1, 6. And then you're going to get a line. Let's see, I don't know how I can do this. Let's see. Get my shape. Whoa, that was not what I wanted. Okay, and then you're going to plot it, and it's going to be a straight line. Okay, let's just back that up because that is not what I wanted at all. All right, so we're going to just draw a straight line as we can through that, and that would be our answer. All right. And then the solution, plotted points, and a prettier line. Okay, next, so we're going to do this one together. Graph the linear equation y equals x plus 3. So if I plugged in a -4 for x, I would get y equals -4 plus 3. So y would equal -1. If I plug in 0, y equals 0 plus 3, y equals 3. And then if I plug in a 4 for x, y equals 4 plus 3, y equals 7. And then you just go and plot those points. So -4, -1, 0, 3, and 4, 7. It's off of the graph. I apologize, but it's going to look something like that. So you would just graph it like that. Okay. All right. And that is a different graph, actually. Okay. So, all right. So you do this one. I'm going to give you a second to plot that. Okay, go ahead and pause it and graph. And your answer should look like this. Okay, practice time. So graph the equation. X equals 2y, x minus 2y equals 6. Okay, so we are just going to plug in some numbers for x to see what y would be. I'm going to go ahead and plug in, like, I don't know, let's do a -3, a 0, and 3 and see what happens. The numbers here are not special. You just plug in whatever you want. So -3 minus 2y equals 6. Add 3 to both sides, so I get 9. Divide by 2, that would give me -4.5, which is not pretty, but we can do that. So -3, -4.5 would be about here. If I plugged a 0 in, I would get 0 minus 2y equals 6. So that would, if I divided by the -2, that would give me a -3. 0, -3. And if I plugged in a 3 for x, subtract 3 from both sides and divide the -2, that would give me -1.5. So 3 and -1.5 would be around here, and then I would draw that line just like that. Now, the good thing about this is no matter what numbers you plug in, your line should look the same. All right. So we are going to graph and compare the two graphs, okay? So if I plug in a 1 for x, what would my y be? If I plugged it in this equation right here, my y would equal 3 times 1, so 3. 0 times 3, or 3 times 0 is 0. 3 times -1 is -3. Now, on this one, all I'm doing is taking those numbers and I'm adding 4. So 3 plus 4 is 7, 4 and 1. All right, now let's graph both of these lines. So the first thing I'm graphing is the point 1, 3. Then I'm going to graph 0, 0, and then -1, -3. And so I'm going to do, this is my line in purple. Let me do a line in orange too. Okay, so now I'm going to plot 1, 7, which is off of the graph, say up here somewhere, 0, 4, and -1, 1. And that is the graph. So how does it compare? It's just shifted up 4. So that makes the whole graph shift up. 4 places. All right, so let's do the same thing with this one. Graph the linear functions y equals negative 4x and y equals negative 4x minus 5 on the same axis. Okay, so if I did, if I plugged in a 1 right here for this x, so y equals negative 4 times 1, I would get negative 4. 0 times negative 4, negative 4 times negative 1, negative 4 times negative 2. Now, if I did that and I just subtracted 5 from each of these, I would get negative 9, negative 5, negative 1, 8 minus 5 is 3. Okay, so the first thing that I'm going to do is plot the these first two. Okay, so negative 1, I'm sorry, 1, negative 4, 1, 2, 3, 4, 0, 0, negative 1, 4, negative 2, 8 is off of the graph, so I'm not even going to bother about graphing that one. And let me try to get it straight. Oh, that's horrible. That's really a bad line. I apologize. That's sad. Okay, and then I'm going to do this one in a prettier blue. Okay, so 1, negative 9 would be way down off of the graph. 0, negative 5, I can do that. Negative 1, negative 1. So right now I'm plotting like these two, okay? So negative 1, negative 1, negative 2, positive 3. So how does that compare? This whole thing is shifted down 5. So if you'll notice, this point right here is at 0, 0, and this point 1, 2, 3, 4, 5 is at negative 5. So you're going down 5. So they want you to see that you're shifting. You have a vertical shift down 5. All right, so graphing vertical and horizontal lines. So if you have a vertical line, you're just going to have x equals a number. If you have a horizontal line, you're going to have y equals a number. A vertical line is not a function, a horizontal line is. So to graph x equals negative 3, I'm going to go on the x-axis where x equals negative 3, and I'm going to graph a line. Because not only does x equal negative 3 here, but it also equals negative 3 here, and here, and here, and here, and all the way down. Okay, now to graph y equals 3, I'm going to go on the y-axis where y equals 3, and I'm going to graph all these points, because y doesn't just equal 3 right there, it equals 3 all the way across in infinite directions. So I know I've got this when I can identify, it's not identity, identify linear equations, graph a linear equation by finding and plotting ordered pair solutions. Do you really understand? Give an example of an equation that is a linear equation and one that is not, and describe how you could use ordered pairs to graph the linear equation. Well, give an example of one that is not, one that is, and one that is not. Let's see, one that is would be y equals 2. One that is not is x equals 2. Also, a linear equation, you could have something like x plus 5. One that is not would be like y equals the square root of x. That's not linear. Describe how you could use ordered pairs to graph the linear equation. I would say substitute numbers for x to find out what y is, and then plot those coordinates. All right, I hope that has taught you something about graphing linear equations.